This is the section 1.2 Solving Quadratic Equations Part 2 video. In the last video, we focused on solving quadratic equations by factoring. The problem with that method is not every quadratic equation is factorable. So if you are dealing with an equation that's not factorable, or even if you just are looking for another method, let's say you really dislike factoring, what you can always use for a quadratic equation is the good old quadratic formula. The quadratic formula says when you have that quadratic equation in standard form, so you have some number a times x squared plus some number b times x plus c equals 0, where a, b, and c are real numbers and a cannot equal 0, x equals the following formula. So that formula is negative, it starts with a negative sign to begin, negative b plus or minus the square root of b squared minus 4 times a times c all over, so that whole thing is divided by 2 times a. So once you identify a, b, and c, which are part of the equation in standard form, you can see I'm circling them now, you just simply plug into this formula and then you simplify the formula as much as you can. You will have up to 2 answers for each question. You're still actually just finding x-intercepts for these parabola shapes. So starting with part A, for all these examples we're going to solve by using the quadratic formula. A has 2x squared plus 5x equals 2. So just like when we were solving by factoring, the first step is to get the equation into standard form. So get the equation equal to 0. So if there's anything other than 0 on the opposite side from the x squared term, move it over. So I'm going to subtract the 2, do the opposite operation to 2 to move it to the other side. Now when I rewrite the left side in descending order, that's the biggest exponent on x on down, I'm going to bring down the 2x squared first, then the plus 5x next, and then the minus 2 equals 0. So there's step 1, get the equation into standard form. Once it's in standard form, then you can identify a, b, and c. So a is the number times x squared, which is 2. B is the number times x, which is a positive 5. You scoop up the sign with it. C, the number by itself without the letter, is negative 2. So now let's go ahead and plug in to that quadratic formula listed at the top of the screen. So x equals negative, I know it feels weird to begin with a negative sign, but the formula begins with a negative sign. Negative b was 5, so negative 5 plus or minus the square root of, now under the square root it says b squared. Again, b is still 5, so 5 squared minus 4 times, I'll use parentheses for times, a, which was 2, times c, which was negative 2. All over, so that whole right side has a fraction bar. 2 times a again, which is still 2. Now let's use order of operations to simplify it to get it down to one number under the square root symbol. So bring down the negative 5 in the top left corner, bring down the plus or minus. Bring down the square root symbol. Under the square root symbol, I'm going to do the exponent, 5 squared, so 5 times itself is 25. Then I'm going to multiply next this glob of terms, the negative 4 times the 2 times the negative 2. What I like to do is I take care of the signs first. So I have a negative times a negative for positive. Then I'm going to worry about the numbers. 4 times 2 is 8, times 2 is 16. All over, so bring the fraction bar down. On the bottom we had 2 times 2 for obviously 4. continuing onward, so we have -5 on the top left corner, plus or minus square root. Let's add those numbers that I have in blue pen together. So 25 plus 16 is 41. And the whole thing is still being divided by 4. We don't know if we're done yet or not until we check to see if the number under the square root simplifies further. So get it down to one number under that square root in the formula and then check to see if that's going to go further yet. I'm going to erase some of this big old handwriting and move what I currently have to the top just to create a little bit more room here. So I currently have -5 plus or minus the square root of 41 all over 4. And we're checking to see if the square root of 41 is going to simplify any further or not. So to do that, thinking back to how we simplify square root numbers, scoop up just the number under the square root symbol, that's the 41, and go ahead and draw a prime factor tree for it. Now, is there anything besides itself and 1 that divides into 41? No. So this is already a prime number. There are no multiples other than itself and 41 that go back in. So that means I cannot find a matching pair of the same prime number, which means that the square root of 41 is already simplified. Yay! So this is the nicest scenario that could happen, is that when you get it down to one number under the square root, it could potentially not simplify any further. So let me just draw that a little bit nicer. So this is actually representing 2 answers. If you were going to type each one of these in one at a time into your calculator, it would simplify to these really weird, yucky decimals. But since we want an exact answer in mathematics, you would leave it just like this. Now, I believe that my Math Lab homework is going to have you simplify these 2 answers, potentially in a solution set, which is the curvy brackets. So I'm going to do the smaller answer first. So -5 minus the square root of 41 all over 4 is what I would type in first, comma, and then do the -5 plus the square root of 41 all over 4. So when you're left with a plus or minus mess, go ahead and separate it as 2 answers when you're typing it into the My Math Lab screen. You can get the square root and the fraction bar in there in the answer box from an answer template that'll appear below the question when you click in the answer box. And then you could just use the comma and any sort of parentheses you need from the keyboard. But this would be the solution set down here, which is the final answer. Let's look at some harder ones where the square root at the end does simplify further. Same directions, question B. We're going to solve the following equation with quadratic formula. X squared minus 4x plus 2 equals 0. So step 1, first the equation needs to be in standard form, set equal to 0. This one already is, yay! So since the equation is already in standard form, now we can jump into the next step, identify A, B, C, and plug into the quadratic formula. So A is the number in front of x squared, which is 1. If it just says x squared, it means that there's actually a 1 in front of that. B, the number in front of x, is -4. And C, the number by itself, is a +2. Let me just go ahead and jot down the quadratic formula on this new slide. So we're going to plug into -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So here we go. We begin with a negative sign. B is another negative number. It's -4 plus or minus square root b again, so another -4. Notice whenever I plug in a negative number, by the way, I put in parentheses around that number. That's super important. So again, whenever you're plugging a negative number into an equation or a formula, put parentheses around it. and it's being squared, so that negative 4 is being squared, minus 4 times a was 1 times c was 2, all over 2 times a, which is still 1. Then let's clean it up. So in the front top left corner, negative times negative makes positive 4, plus or minus square root. So here's why I just made a big fuss about make sure you put parentheses around a negative number. When I do negative 4 squared, notice I am squaring the negative sign as well as the 4. So I'm actually doing negative 4 times negative 4, which is positive 16. Now when I multiply, I'm only seeing one minus sign here, so bring the minus sign down. 4 times 1 times 2 is 8, all over 2 times 1 is 2. So it's already looking a little bit nicer, and I'm going to erase to create some more room with my big old handwriting. And after I do that, I'm going to combine the numbers under the square root together to get it down to one number under the square root sign. So I have 4 on the top left corner, plus or minus square root. I have 16 minus 8, which is obviously 8, all over 2 on the bottom. Okay, so even though this is the right answer, if you typed this into the MyMathLab, it would say wrong, because the square root of 8 does simplify further. So to know that for sure, we got to draw that factor tree. So off to the side, I'm going to do a prime factor tree for 8. So 8 is 2 times 4, and 4 is 2 times 2. Because I have at least one matching pair of the same number, that means I can break down that square root a little bit further. So let's go ahead and bring down the 4 on the top left corner and the plus or minus. Actually, I'm going to leave a little bit of room before I draw the square root symbol. And I'm rewriting 8 as 2 times 2 times 2. We're using just the prime numbers. And then it's all over. There's still that 2 on the bottom. So we said for every matching pair of numbers, kick out that number, meaning multiply it in front of the root. So when I do the square root of 2 times 2, I get out another 2. Notice when I kick it out, that number 2 out to the front, it goes after the plus or minus symbol so that it's being multiplied by the square root symbol. What I actually did here was the square root of 4. The square root of 4 equals 2. So I now have 4 plus or minus 2. Under the square root symbol, there is one lingering number 2. So bring it down all over 2. Guess what? Even though this has been simplified, it's still not going to be what the MyMathLab wants because we can simplify even further. Why do I say that? Because if you break up this fraction, both of the numbers on top are divisible by the 2 on the bottom. So I can break this fraction up to see it better, to show you better what I mean. I could do 4 over 2 plus or minus 2 root 2 over 2. So if both of the terms, both of the numbers on the top are divisible by the number on the bottom, or if there's a greatest common factor other than 1 that goes into all those numbers, that means you can simplify further. If you're not sure if you can simplify further or not, feel free to break it up like I just did into 2 separate fractions. It's a little bit easier to see that way. And now I see we got a 4 divided by 2 for 2. Leave the plus or minus in the middle. The 2's outside of the square root cancel, and I'm left with square root of 2. So finally, we have a simplified answer. We got 2 answers, 2 plus or minus the square root of 2. Now, how is the homework going to want you to type that in? So you would type in 2 minus the square root of 2, comma, and 2 plus the square root of 2 as the final separated answers in the MyMathLab homework. So this is a worst case scenario, is when the square root simplifies, and then once you kick out some of the number, you can break it up into two fractions, and that also simplifies. So this is the worst case scenario, and that it just kept going and going and going and simplifying. So you do want to make sure you're checking to see, okay, can I simplify further? Let's look at another scenario that could play out with quadratic formula. Same directions for question C. We're going to solve by using quadratic formula. We have 4x squared plus x equals -1. Step 1, we need to get our equation into standard form. So let's add that 1 to move it over to the left side. Then I'm going to rewrite the mess on the left side in descending order. So I got 4x squared first, then plus x, then plus 1 equals 0. So my equation is now in standard form. After you get the equation in standard form, then you can identify A, B, and C. So A here is going to be positive 4. B, if it just says plus x, we can assume that B is a positive 1. And C is also positive 1. So then you'll want the formula nearby. Keep in mind it's still negative B plus or minus the square root of B squared minus 4AC all over 2 times A. So that's negative, B is 1 this time, plus or minus the square root of B squared, so that's 1 squared, minus 4 times A is 4 times C is 1. All over 2 times A was 4. Simplify, especially what's under the square root, get it down to one number. So -1 plus or minus the square root of 1 squared is 1. I only see one minus sign, so it's going to be minus 4 times 4 times 1 is 16. All over on the bottom, we got 2 times 4 for 8. Keep going. So -1 plus or minus the square root of 1 minus 16 is a -15 all over 8. So when you get down to the end and you have the square root of a negative number, that does not exist. If you type in the square root of -15 into your calculator, it's going to say error, no real answer. It's some imaginary answer. Since we don't care about imaginary numbers in this course, you would select from the multiple choice options in the homework, no real number solution. So again, after you use the quadratic formula, if you're left with a negative number under your square root symbol, you're going to automatically select no real number solution as the final answer. So in other words, if you were to graph the quadratic equation that's set equal to 0, that was the 4x squared plus x plus 1 in your graphing calculator, you would end up with a parabola that never touches the x-axis, and it opens away from the x-axis. So that's why there are no x-intercepts, or in other words, no real number solution here. So we have one more scenario that could play out with quadratic formula. Let's go ahead and take a look at it. Looking at question part D, it's going to be the same directions. We're going to solve by using the quadratic formula. 9 plus 3 divided by x minus 2 divided by x squared equals 0, where x cannot equal 0. When you see this x cannot equal 0 part off to the side, that's just telling you the domain, because if you tried to plug 0 back into x, you would have zeros on the bottom of the fractions, and we can't have that in math. We cannot divide by 0 in math. Let me go ahead and draw this back here. So in other words, you can ignore that x does not equal 0 part. So I'm going to go ahead and scribble out this x cannot equal 0. Just ignore that. That's not going to factor in to our equation at all. So the first step, get the equation in standard form. Well, it is set equal to 0. However, it's not even a quadratic equation yet since we're dividing by x. So we need a trick to clean up this equation to get it to be a quadratic equation. Let me go ahead and rewrite this a little bit larger, and then we'll talk about what to do. So I have 9 plus 3 over x minus 2 over x squared equals 0. So what you're going to do is you're going to need to get those x's up to the top of the fractions. You don't want the variable on the bottom of the fraction. It's not even a quadratic equation yet. So you're going to look for the biggest powered x, which is x squared in this case, and you're going to multiply both sides of the equation by x squared. In other words, you're going to multiply every single term on both sides of the equation by x squared. So I'm going to multiply the 9 by x squared. I'm going to multiply that 3 over x by x squared. In other words, x squared over 1 technically. So notice that when I do that, I'm only multiplying the 3 on top of the fraction by x squared technically. I'm going to multiply this 2 by x squared, or x squared over 1. And yep, I'm even going to multiply the 0 on the right side by x squared. I'm using a dot for times with some of these terms. Okay, so let's see what happens when we multiply every single term by that x squared. It's going to get rid of the x's that are on the bottom of these fractions. So now, if I rewrite what we now have 9 times x squared plus, I have 3x squared over x times 1 over x. 3x squared divided by x is just 3x when that's all said and done and simplified. Bring down the minus. These x squareds cancel, and I'm left with a negative 2 over 1, or a negative 2, equals 0 times anything is 0 again. So now I actually have a quadratic equation. I have 9x squared plus 3x minus 2 equals 0. So again, when you see something similar in the homework, ignore the x cannot equal 0 domain. That does not play any role in actually solving this quadratic equation. And your first step is to multiply every single term by x squared to get rid of the variables on the bottom of the fractions and to make the equation a quadratic equation. So now we can use the quadratic formula. It's in standard form. It's set equal to 0 even. So our a is 9. Our b is positive 3. And our c is negative 2. And this one is going to be a lot of simplifying because it's actually a factorable equation. So let's see how far that simplifies when we choose to use quadratic formula instead of factoring. So x equals negative b, which is 3 this time, plus or minus the square root of b squared, so that's 3 squared, minus 4 times a was 9, times c is negative 2, all over 2 times a was 9. So as usual, let's get it down to one number under the square root symbol to see if we can go further or not. So we have negative 3 plus or minus square root, 3 squared is 9. I have negative times negative for positive. 4 times 9 is 36, times 2 is 72. All over on the bottom I have 2 times 9 for 18. So now we have negative 3 plus or minus the square root of, when I do 9 plus 72, I have 81 all over 18. I'm going to erase to get some room, to make some room with my big old handwriting here. But usually when we get to this step, we draw a factor tree for the number under the square root symbol to see if we can simplify that square root further or not. And you can do it that way. However, there is a quicker way. If you look closely, the square root of 81, well, 81 is a perfect square. It's a perfect square of 9 because 9 times 9 gives you back the 81 under the square root. So no matter which way you do it, in your head or draw on the prime factor tree, you're going to see that you're going to be able to apply the square root to the entire number 81, so you just get back 9. So when you do that, the square root symbol is gone completely since you've applied it to the entire number. So we have negative 3 plus or minus just 9 over 18. Since these are the same types of numbers without a square root symbol, we can simplify it even further, unfortunately. So let's go ahead and break it up into two answers. We have negative 3 plus 9 over the 18 to simplify, and we also have negative 3 minus 9 over the 18. If I go back up to the negative 3 plus 9, that's 6 over 18, which reduces to 1/3. If I go down here, negative 3 minus 9 is negative 12 over 18, which reduces to negative 2/3. Now, if it's been a while since you've worked with fractions and you're going, okay, how did you reduce that so quickly? You can either reduce in your head or you can make the graphing calculator reduce for you. So if you're doing it in your head, if I go back to the 6/18, the first answer I had, I asked myself, what's the biggest number that divides into the 6 and the 18? Well, that would be 6. So if I'm doing it in my head, I would divide the top and bottom by the biggest number that divides into those numbers, which happen to be 6. And the negative 12/18, 6 was also the biggest number to divide into those two. So when I did like the negative 12 divided by 6, I got negative 2. When I did the 18 divided by 6, I got 3. However, if you're not a fan of fractions, you don't have to do it in your head. You can also make the calculator, the graphing calculator that is, reduce for you. So let me go ahead and bring my graphing calculator onto the main screen, and I can show you where that button is to reduce fractions. Starting with the 6/18, to see if that will reduce further, let's type that into the calculator. So I'll type in 6. Fraction bar just means division, so divided by for the fraction bar. 18. Now to see if this fraction reduces, you're going to hit the math button, which is the third button down on the left side. So I hit math. I select frac, option 1. So I'm going to hit enter on frac. Frac comes onto the main screen, and then I hit enter a second time. And it does reduce to 1/3. Let's try the other fraction, which was that negative 12/18. So if it's a negative number, I'm going to use the negative sign on the bottom row, not the subtraction symbol. If you do it wrong, it's going to say error in the calculator. So here's the negative sign on the bottom of the calculator. 12 divided by 18. And just think math button, enter twice. So math button, frac, enter, and then enter a second time. Math, enter, enter. For negative 2/3 is what that fraction reduces to. So if they want the answers as a solution set, we got negative 2/3, comma, and positive 1/3. But this is the fourth and final scenario that can play out with quadratic formula, where the square root can be applied to the entire number, so the square root symbol goes away, and you could just keep simplifying it down to those up to two final answers.